In this example, a man walks 4 kilometers at 30 degrees west-northwest, and then he walks 5 kilometers at 15 degrees north-northeast. The question is, how far and in what direction must he walk to get back to where he started? Let's draw a little sketch of the situation. Each set of vectors can be represented. They don't have to be exactly to scale, but something close is great. Then we can find our resultant, and the opposite of that resultant will be the equilibrant. For the first vector, the x component is adjacent to the angle, so we're going to use cosine. Ax equals a cosine theta. Plug in our numbers and we get 3.464 kilometers. Do the same thing for y with sine. And our first vector is 3.464 kilometers I hat plus 2 kilometers j hat. Do the exact same thing with b to get 1.29 kilometers I hat plus 4.83 kilometers j hat. Oh, and one more detail we don't want to forget. Our x component of vector A has to be negative because it is in the negative x direction. So let's forget about all this other stuff and just take these two vectors. Group the x components together and group the y components together and add them up. Minus 3.464 plus 1.29 is negative 2.174 kilometers. While 2.00 plus 4.83 is 6.83 kilometers. The equilibrant is of course the opposite of the resultant. Use the Pythagorean theorem to find the magnitude of 7.17 kilometers, and whatever trig function makes you happiest to get 72.3 degrees south-southeast. And we are done. Okay, so on this problem we have a boat, and this boat wants to go directly west across the Mississippi. So it wants its resultant velocity to be this way. But the boat can travel at 8 miles per hour. The Mississippi is flowing at 5 miles per hour. So the Mississippi is already flowing south at 5 miles per hour. This is an unknown resultant right here. And so in what direction should the boat travel? So what you want, in other words, what this problem is asking is, what do you add tip to tail to this 5 mile per hour velocity in order to get this resultant? And I hope you can all agree that clearly we need to add that. This is an 8 miles per hour vector. At some angle, clearly the boat is going to have to travel northwest. West in order to make its way across the river, and north to fight its way upstream, or at least prevent itself from going downstream while it travels. So we have a triangle that looks like this. We have a variety of unknowns. So the great thing about a right triangle is that as long as you have one side and at least one other piece of information, be that another side or an angle, you can find everything else involving trig. So this suddenly just broke down to not really being a physics problem and being more of a trigonometry problem. I have something with a hypotenuse of 8 and a side of 5. What is this angle? Well, I have adjacent over hypotenuse. Then theta is going to equal the arc cosine, 51.3 degrees, and our angle, that is west of north, or west-northwest if you prefer, because it's more west than it is north, right? Okay, so that's our angle. What is the resultant velocity of the boat? Well, we just want to find this side, this resultant right here. Well, we have all kinds of ways we could do that because we have all the pieces of the triangle. We could use the Pythagorean theorem and solve for r. Or we could use sine equals, now that we know theta, we could use sine of theta equals opposite over hypotenuse. We couldn't use cosine because it doesn't contain the opposite side, but we could use tangent as well. It doesn't matter. You can do any of the above. I'm going to use sine. And we get 6.24 miles per hour. The final question, how long does it take to get across? Well, we haven't actually done this yet, but velocity is distance over time. All right, and if we solve this for our time, we get time equals distance divided by velocity. And if you solve for that, you get this weird number of 0.080 hours, which if you ever answered a question with 0.08 hours, people would say, what? So if you multiply that by 60, you'll get 4.81 minutes, and even better, you can multiply that 8 by 60 seconds and you can get 4 minutes and 48 seconds.